Okay. So, firstly, good morning, everybody. It's a real pleasure, sincere pleasure, to be with you this morning and have the opportunity to speak with you. My name is Paul McDonagh-Smith. I'm a senior advisor and adjunct faculty of digital learning here at the Africa Business School. As I said, I'm very pleased to have the opportunity to meet with you all this morning, and really do thank you for taking the time to be here with us. At this very trying time, of course, as well, I hope you and your families are all healthy and well. In today's webinar, which is the first of 3 to be delivered on consecutive Monday mornings, I'd like to speak with you about the evolving role of technology in our lives and work. And just to put this into context for a moment, in this first webinar, we'll talk about, as we said, the role of technology, how it's being recalibrated, the relationship we have with technology and machines, both in our lives and work. And then in the next webinar, next Monday morning, we'll look at how we can effectively use technology to create our own learning toolkits and learning solutions. And then in the third webinar, in 2 weeks' time, we'll talk about how we actually effectively apply the learning strategies that we've developed with technology in our teams, individually, in our organizations, and in fact, more broadly in our society as well. So, of course, with this being the first webinar, I hope this is just the beginning of our relationship and we get to spend more time together over the next weeks. Now, over the next 25 minutes or so, we'll define and give examples of digital learning. Once we've done that, we'll introduce a periodic table of digital technology elements, which illustrates the families of technologies that we have at our disposal today. And then, once we've done that, we'll discuss 2 very key concepts that actually help us understand where we are with technology today and, importantly, how we got here as well. Now, as we go through today's session, if you have any questions that you'd like to ask, we'll have a Q&A session at the end of this webinar. So please, as we go through the next 25 minutes or so, please feel free to send your questions via the conversation feature, and we'll address as many as we possibly can at the end. If I'm unable to answer all of the questions just because of time, we'll collect them and provide answers to you over the next few days. Also, later this week, we'll provide you with access to a short blog entry that'll summarize key insights from this talk and any of those questions that you pose. Okay, let's get started then. Let's go on a little bit of a journey together. The first stop on our journey is Ghana, where we have a problem that needs to be fixed. Ghana has well-developed cities, a thriving tourist industry, an impressive agricultural and a well-developed mining sector, as well as a reasonably stable government. Other than a few large cities, however, the demographics of the country can be quite challenging. Most people live in small villages, roads disappear quickly at any distance from a larger city, and services such as healthcare and education can be quite difficult to access in the more remote regions of the country. As a result, a significant proportion of the population, nearly 30%, suffers from illiteracy. In a country where nearly 30% of the population is also younger than 15, this is a potentially paralysing fact of life. Just to put this into perspective for a moment, a 30% illiteracy rate in the United States would occur if the residents of the entire western region of the country 109 million people were unable to read. Now, those of us who were taught to read as young children rarely give much thought to the question of what life would be like without it. I'm sure we all know individuals and people who have this challenge, but let's just really consider this reality for a moment. A person anywhere in the world, here in Spain, in the UK, in Boston, wherever you guys are, a person anywhere in the world who is unable to read, can't sign their name, and even if they can, they don't know what they're signing. And in most countries, a signature on an official document constitutes a legally binding contract. They can't read a job application. They can't read the label or instructions on a bottle of medication. They can't help their children with schoolwork, can't read road signs, can't consume a newspaper, magazine, or book, or respond to a text message on their mobile phones. In essence, the only mechanism they have for the absorption of life-changing information is either word of mouth or personal experience, both somewhat dubious sources of first-hand insight, knowledge, and problem-solving skills required for a citizen to function well in our societies. Now, enter Towston at this point. Amongst other goals, the elimination of illiteracy in the developing world is important to the team at Towston. But building schools isn't straightforward in any country, and that's true also in Ghana, where the population is broadly and thinly scattered across a pretty vast and challenging landscape, with little in the way of transportation or roads. Now, instead, Towston turned to a simple but profoundly effective technology solution, the mobile phone. While most people who live outside cities in Ghana might have limited access to wired communications, almost everyone seems to have a mobile device, and a large proportion of villages have also got a shared solar charging station. So Towston took advantage of this. They built a mobile app and made it available to everyone in the country, free of charge. They blanketed the region with voice messaging, designed to spread the word about its availability and to encourage high download levels. Why? Because the app is designed to take a person who is functionally illiterate and in roughly 7 weeks progress them to a functional reading level. No classroom, no teacher, just a handful of mobile technology and a will to learn. And the results, very impressive. Now, this is a powerful example of digital learning. When applied to real human problems, the challenges that impede individual and collective progress can be converted by digital learning to opportunities to improve how we all live and work. Digital learning, the practice of achieving learning outcomes through a considered and focused application of technology, is the focus of our conversation today. We don't need to go as far as Ghana to find useful examples of digital learning. Here at OCP, UM6P and Africa Business School, we're very, very keen to experiment our way forward with digital learning and teaching by conducting experiments to understand the role technology can and should play in our online and in-person teaching and learning experiences. Let me just give you a couple of brief examples here. So back in 2012, when Hurricane Sandy hit the east coast of the United States, it prevented scores of participants from traveling to Cambridge, to Boston, to attend an exciting new program I was involved with on big data at MIT. Now, the MIT team in charge of the program had to come up with a quick solution that would provide an engaging online experience for those who couldn't get to campus. So what began as an improvised online simulcast to mimic a classroom experience evolved into a product titled 4DX, an avatar virtual world experience that expanded the learning possibilities available in the physical world. Again, as with Toaston, an example of using digital learning to fix a very real and at the time current problem. At OCP, UM6P and Africa Business School, we recognise that technology is fundamentally a human enabler. We also see that at its best, it's not just satisfied with aiming to replicate our physical or mental limits, but instead to allow us to exceed them, to enable us to travel further, build higher, and realise more of our individual and collective potential. It was in this spirit that MIT Sloan launched a telepresence robotics project to enable individuals with mobility impairments and challenges to participate in open enrollment programs. The inaugural participants on this program, a chap called Tom Hershey, provided the following quote in his feedback interview. He said that the robot is an opportunity, not a substitution. Now, Tom's point about the robot representing an opportunity, not just a substitute for a physical experience, is a very powerful idea for us to keep in mind as we look to build and implement digital learning. Digital learning doesn't need to reflect the learning objectives, user experiences, or the business models of the physical world in which it was built. In fact, as you can see from the photographs here on this slide, here at OCP, UM6P and Africa Business School, we're also interested in experimenting with robotics in a number of use cases, including working, meeting, teaching, learning, as well as remote visits and interactions. And you can see the pictures here taken, I think, a couple of weeks ago, just show some initial kind of use of the robot at the OCP offices in Casablanca. And as we move forward, of course, with these experiments, we look forward to sharing the results with you in the very, very near future. Now, when we think about building the teams, organizations, cities, and in fact, society of tomorrow, we invariably look to technology to lend us a hand. Indeed, our visions of tomorrow are shaped by innovations delivered by the algorithms running in code on our computers, laptops, and smartphones. To create and enroll our teams on the visions we build, we need to lead and manage with an appreciation of the principles and possibilities of the digital technologies we have at our disposal today. With this in mind, let's look at this concept called the periodic table of digital technology elements. Back in 1869, when Mendeleev published his first version of the periodic table, he referred to it as an attempt towards a chemical conception of the ether. In a sense, what we're trying to do with this version, which is focused on digital technologies, is an attempt to provide a way of ordering our business thinking about the various families of transformative technologies that have the potential, that are in fact disrupting our businesses today. As with the chemical elements, a number of the digital technology elements can combine to form more complex and valuable molecules. Where sodium and chlorine combine to form standard table salt, AI and robotics, for example, can combine to form products such as the telepresence robotics example I talked about just a few moments ago. Now let's do a super quick review of our 10 periods of our periodic table. On the left, we begin with the AI family of technologies. As we move across the table, we encounter the periods of security, robotics, crypto, computation, unified communications, mobility, IoT, mixed realities, augmented and virtual, and then finally, taking up the position usually reserved for the noble gases, we see the period of analytics, where the elements enable us to create practical, useful ionic bonds with the data we're collecting as a result of our application of digital technologies. Now, one thing we haven't spoken about here is the human element, or the human elements of our periodic table of the future. As the human and machine relationship is recalibrated in today's digital economy, we can expect, as Mendeleev recognized in his elegant design, new elements to be unearthed and added to our table. A number of these elements will reflect our new partnership with digital technologies. We might reasonably expect, for example, elements of empathy, collaboration, communication, digital culture, digital language, digital super senses, and algorithmic business thinking to form a further period on our table, and in doing so, recognize some of the molecular foundations of tomorrow's teams and organizations. Now that we've introduced the idea of a periodic table of digital elements, perhaps we should reflect for a moment and think about where we actually are today with technology and how we got here. So I'd just like to ask you just for a moment, just to think a little bit. It's one of those very obvious types of questions, but perhaps one we don't ask ourselves very often. During our lifetimes, we've seen a massive change to the way we interact, the way we communicate, collaborate, connect with people, places, processes, etc. How often do we actually take a step back and think about where we are with technology? And so I think there are two concepts that are particularly useful for understanding where we are today and, very importantly, how we got here. The first, and perhaps the better known, is Moore's law, which is an expansion of an observation made by Gordon Moore. You can see his picture here on the left, co-founder of microprocessor maker Intel. In a 1965 article in Electronics magazine, Moore noted that the number of transistors in a minimum cost integrated circuit had been doubling every 12 months. He predicted that this same rate of improvement would continue into the future. When this proved to be the case, Moore's law was born. Variations of Moore's law have been applied to improvement over time in disk drive capacity, display resolution, network bandwidth, and lots of other areas. The second concept, relevant for understanding recent computing advances, is actually closely linked to Moore's law. It comes from an ancient story about math, made relevant to the present age by the innovator and futurist Ray Kurzweil. In one version of the story, the inventor of the game of chess shows his creation to his country's ruler. The emperor is so delighted by the game that he allows the inventor to name his own reward. The clever man asks for a quantity of rice to be determined as follows. 1 grain of rice is placed on the first square of the chessboard, 2 grains on the second, 4 on the third, and so on, with each square receiving twice as many grains as the one before it. The emperor agrees to this, thinking that the reward was way too small. He eventually sees, however, that the constant doubling results in tremendously large numbers. The inventor winds up with a pile of rice bigger than Mount Everest. In some versions of this story, the emperor is so displeased at being outsmarted that he beheads the inventor. Perhaps this is a cautionary note that no one really likes somebody to be overly smart. In his 2000 book, The Age of Spiritual Machines, when computers exceed human intelligence, Kurzweil notes that the pile of rice is not that exceptional on the first half of the chessboard. After 32 squares, the emperor had given the inventor about 4 billion grains of rice. Now, that sounds like a lot. It's a reasonable quantity, about one large field's worth of rice. And the emperor did indeed start to take notice. However, at this point, the emperor could still remain an emperor, and importantly, the inventor could still retain his head. However, it was as they moved into the second half of the chessboard that at least one of them, the emperor or the inventor, was going to get into difficulty. So, for over 50 years now, the number of transistors you can put on a chip has been doubling about every 18 to 24 months. And that means the power of computing that you can get for $1 has been dropping by 50% year in and year out. Going back to chemistry terminology for a moment, catalyst might be a good way or a good word to describe Moore's law. It's one of the most important things that's been happening in the global economy over the past half a century or more. But it brings up a very interesting point. Moore's law has been going on for more than half a century, but we're only just really seeing all of these weird science fiction type technologies, self-driving cars, computer chess champions, computer Go champions, poker champions, etc. Why is that? My colleagues at MIT, Eric Brynjolfsson and Andy McAfee, shared with me that they had done a little calculation on this. They looked up when the United States government actually started tracking this new thing called information technology as a category that business could invest in. It appears that 1958 was the first time we saw the words information technology referenced in the US national statistics. Taking that as a starting point, let's use a year and a half as the doubling period to have a sense of when we entered the second half of the chessboard with the business use of digital technologies. If you do that calculation, it turns out we entered the second half of the chessboard in about 2006. Now, my colleagues, Eric and Andy, stress that this is somewhat of a back of an envelope type of calculation, and we shouldn't read too much into it. We shouldn't overly read into it. That said, on one hand, it helps us understand the smartphone era, self-driving cars, drones, computer Go champions. All of these technologies have happened since 2006. We might suggest that they are second half of the chessboard technologies. It may be no more than a directional observation, but it's also a very serious one, because people say, well, Moore's law just keeps doubling. Why are we suddenly seeing this takeoff? And yes, we've had millions and even billions of transistors on a chip, but now we're getting to astronomical numbers, and we're getting beyond what most of us are used to comprehending. It's not just a few fields worth of rice. It's not numbers that we're actually used to dealing with as human beings. And we're getting power in computers that were never seen before. Kurzweil's point is that constant doubling, reflecting exponential growth, is deceptive because it's fundamentally, initially unremarkable. Exponential increases initially look a lot like standard ones, but of course they're not. Couple that observation with the calculation that I shared around information technology, and we may reasonably conclude that we're in the early stages of the second half of our digital technology chessboard. If that is the case, we haven't seen anything yet, and we should look to fasten our metaphorical seatbelts, for quite a ride in the months and the years ahead. While I think it's fair to expect that we'll encounter a certain amount of disruption to our lives, organisations and society, as the implications and applications of technology reach further into our work and our lives, it's also very important to remember that this disruption brings great opportunities also. Digital technologies are recalibrating key relationships, including how humans and machines actually work together. In our next webinar, at the same time next Monday, we'll explore how digital technologies are actually recalibrating how we teach and learn. We'll discuss how we can harness technology to build personalized digital learning strategies that bridge the gap between where we are today as individuals, as well as collectively in our teams and organizations, and where we need and want to be. Then, in the final webinar of this short 3-part series, we'll look at how we can pragmatically apply digital learning to improve our lives, our teams and organizations. Because having a digital learning strategy and actually executing it are two very, very different things. I hope you've enjoyed our short journey this morning. We've moved from introducing digital learning. We spent a little bit of time in Ghana. We then looked at our periodic table of digital elements. And then I tried to use Moore's law and the technology chessboard to explain where we are today with technology. Now, at this point, I'll pass you back to Rita to go through any questions you may have shared during the webinar. Thank you very much for your attention, and I hope this was useful for you in some way. Thank you.
Thank you, Professor. Hello everyone. I will go through your questions, and the first one is the following. Let me read it for you.
Thank you.
So, to design digital learning solution, do you consider we have to change or update incrementally the existing class materials, or should we disruptively reinvent it based on the instance of the periodic table?
I think, but based on it's a great question. Firstly, so based on my experience over the last 10, 15, 20 years, I would say that the first thing to bear in mind is technology should work for us. We can't abdicate, and we shouldn't abdicate our responsibility to making decisions and kind of driving things forward. The way that we teach in our physical classrooms, it works really well. When it's done very well, it's fantastic. The engagement, the immersion, the energy, all of these types of things are absolutely central to good teaching and good learning. So I would argue that we've already got the foundation. We know what we have to do, and we should be looking then to find technologies that allow us to replicate that energy, that excitement, that immersion, the engagement in a digital way, so that more people in different places at different times can access the learning. So I think to be clear, what I'm saying is that we shouldn't look necessarily to completely change what we have. We should be looking to bridge the best of what we've had or what we've got into a digital environment. And so this is where the periodic table becomes really important, because we have all of these different periods, these different families. Each element has a different capability. When we talk about AI technologies, there's a lot of myths around kind of what AI can do for us today. But we have to try and find the ways in which those technologies can actually help us replicate the energy, the immersion and the engagement. So let's just remember that technology works for us. And when we get into the next webinar next Monday morning, I'll be happy to kind of talk more about how we pick and select the technologies we should be using. Thank you.
So for the second question goes as follows: how can we benefit from the current situation that introduced or imposed digital into the learning journey for students to shape the past for the future when this institution of learning and school are impregnated with the digital?
Okay, so just for clarity, just to confirm, the reality we're referencing is the COVID-19 coronavirus reality. Is that correct?
I think so.
Okay.
Yeah.
Okay, so as I said at the very beginning, this is a very trying time, isn't it? And without, whilst wishing to respect all of the difficulties and all of the challenges, that there's a part of us that has a responsibility to recognize kind of the opportunities to kind of create and shape a better future, a better tomorrow with all of this. So I think one of the ways I would express this is almost like a double helix type of approach. So kind of when the kind of the founders or the inventors of kind of DNA of the double helix, if you kind of apply that metaphor to teaching and learning, you could suggest that digital and physical kind of need to work together. Okay, so I would argue, or I would suggest, that the key thing here is kind of taking a step back and looking at the learning objective, and then based on the learning objective, determining whether an in-world experience is kind of better or a digital one will work better. And of course, at the moment, a number of us, if not all of us, are kind of working remotely. I think we have an opportunity to get better at using digital technologies. It's very hard. If you think about this as a toolkit, a tool set, if you think about kind of, your parents or grandparents and the tools that they use to do their job, whether it's in a kitchen or kind of in a workshop, we all know, don't we, that those people are very skilled at using the tools. You can't create anything very, very, very great unless you know how to use the tools. So I think we have a very big opportunity in front of us to become better at using digital tools and to respect and understand that the world we're moving into is always going to be a combination of digital and physical. That's not to be negative about the benefits of physical learning, because we're human beings, we're social animals, we like to be together, we kind of, it's hardwired into us. But at the same time, we're living increasingly in a world that's globally, digitally connected. And so understanding how these tools work, same as our kind of dads and granddads and mothers and grandmothers were able to use their tools very well, our generation and our children will kind of grow up using digital and physical tools together. Okay, so I like that idea of a double helix, if that makes sense. Thank you, Geeta.
The third question goes as follows. Can digital learning become the primary channel for state-run programs? Are there any success stories?
There are, and there's also kind of an example. I suppose history kind of is very, very important. If any of you have met me before, you might have heard me talk about this, that I'm very kind of keen on the idea of digital presentists. Yeah, that we shouldn't be digital futurists. We should be digital presentists, kind of interested in what we can do today with technology, not kind of where technology is going tomorrow, but kind of what we can use it for today. And it makes me think historically, if I think back 15, 20 years, I worked for a company called Nortel, a Canadian telecoms company. And I did lots of different jobs there, engineering stuff, as well as R&D and HR, learning and development things. And I remember e-learning, we used to call it. And we used to use a lot of e-learning for statutory kind of obligatory type of training. So we had, the government would impose, different governments in different countries would impose kind of learning requirements, that you had to do ethics training, you had to do XYZ type of training. And where it was informational, we often used technology. We would send out CDs, DVDs, that type of thing, and people would kind of, complete the training. Now, the reason I say that story is that if you fast forward to today and fast forward to tomorrow, the technologies we have at our disposal are infinitely more powerful. We're on the second half of the chessboard, to use the kind of metaphor. And so with these new technologies, we can do more than just kind of broadcast information. We can allow people to connect and collaborate and work together, which means that the type of training and the type of learning that we can achieve is really, really different. Now, the extent to which governments will embrace digital learning, I think it's going to be determined by a number of factors. The economy is one of them. So in my work at MIT, we're thinking very seriously around the next year, particularly kind of the next year, but also the next 2 or 3 years. And part of our kind of thought process is, well, what's happening in the world around us? So if you look at something like the Porter's 5 forces, what are the forces that are impacting upon our organizations and on our reality? And the economic kind of push of this, once we come out of this COVID-19 situation, the world's going to be a little bit different, of course, and a requirement for retraining, a requirement to kind of deal with unemployment, all of these types of things might actually force certain governments into an accelerated use of digital technologies. So in all of this, I mean, we have no way of predicting the future. I kind of heard a very funny thing from one of my kind of MIT colleagues who said that the problem isn't predicting the future. The problem is knowing when it's going to happen. Yeah. So I think all of us on this call today, we have an appreciation that digital technologies, digital teaching, digital learning is going to become more of our lives. But when and in what way, it's hard to tell, isn't it? So the best we can do is kind of begin to prepare ourselves and experiment and kind of get better with the various technologies we have in front of us. Is that okay, Rita, as an answer?
It works for me.
Thank you.
So I think that we have time for one last question. Do we have to stick to the chess framework, or should we expect less or more doubling capabilities in the future, especially regarding processors and calculation materials? And also, what about combined calculations done by several machines? Do we know roughly their limitations and thresholds?
That's a fantastic question. In fact, all of the questions have been great, Rita. So thanks to you for sharing them, but also thanks to everybody for kind of putting them forward. We don't know, do we? I think that this is always one of the challenges. We look for kind of, in my work, very much look to be data centric and data focused, and that's why I kind of use the example of Moore's law, because over a period of 50 years, more or less, it's shown itself to be true. Okay, so it's a very useful kind of marker. It's a very useful kind of marker in the sand, something to kind of lean upon as we try to understand what's going on. Those of us, or those of us here together today who are very interested in technologies, will kind of be reading things about quantum computing and quantum physics and supercomputing, and it's hard to tell, isn't it? But what we do know, based on our kind of application of Moore's law and the idea of exponential growth, we have a logic and a rationale and data to show how we got to where we are today. How this moves forward, at the very least, we should expect to be very surprised over the next years. As human beings, we're not very good at kind of dealing with the idea of exponential growth. We're very linear in lots of ways. And so we have to kind of almost take a step back and free our minds a tiny bit and just be ready to be surprised and ready to react. I'm very much reminded of kind of a quote by Lord Brown, who was the chairman of British Petroleum, BP, and he said something along the lines that everybody and anybody in the organization who's not responsible for selling products, making or selling products, is there to support the making and selling of their product. And that might seem like a very simple thing to say, but in this regard, in this respect, I would say that kind of just highlights the fact that we all have to try and be supportive. What's very important is that we have an organizational direction, a societal direction, and that we're all playing our small parts in all of that. So the changes are going to be incredible. Yeah. The implications and the applications, well, the implications are going to be mind-blowing, and the applications are down to us. It's down to me, you, Rita, everybody. We have to have the creativity to understand how we're going to apply the opportunities or convert the opportunities we have into value. Okay, so we should be ready to be surprised and kind of not be judgmental, and just have a process for thinking about how we're going to work on all of this moving forward.
So I think that we have many other questions, but unfortunately we don't have much time. So what about I send you those questions by email? Please. And feel free. Yeah. So let's do that and let's wrap this session. Thank you, Professor, and thank you all the participants for your presence.
Thank you so much, everybody. It was a pleasure. Thank you.
We'll see you in a week time for the next one.
Yeah, please come back, everybody. Yes. Thank you.
All right. Have a good start of the week and have a good day and stay safe.
Thank you.
Goodbye, everyone.